Let's look at another radical. What if we have the 8th root of x to the 4th? We need to lower the index of the radical. It's not always possible. In rational exponents, you'll see why. This is x to the 4th to the 1/8 power, right? Because the 1/8 power means we're taking the 8th root of the number x to the 4th. But here we have a base to a power to a power. That means we multiply the powers, and so that just becomes x to the 4 times 1/8. And that's the same thing as x to the 4/8 or x to the 1/2 power. If we bring it back into radicals, that's the square root of x. Index of 8, the 8th root of a number, and we were able to reduce that to the square root of a number. So whenever find radicals. Well, let's make a little summary of what we did here by looking at those simplifying radicals. The rules are the following. Sometimes wording in math is a little bit tricky to understand, so sometimes it's a good idea to write it in your own words, and that's what I tried to do with these. The first rule, remember, is to take what you can to the outside of the radical. In math language, that says the radicand has no factor raised to a power greater than or equal to the index. When you read that, sometimes it's a little bit hard to interpret. All that means is take any factor that's a perfect square or cube, as the case may be, to the outside of the radical. The second rule says the radicand has no fraction. No denominator contains stated simply. The third rule, exponents in the radicand and the index of the radical have no common factors. So, sort of in plain language, that means reduce the index of the radical if possible. Maybe a word that may be hard to interpret what that says. Rules in simplifying radicals. Take what you can, whatever factor you can, to the outside of the radical. Remove all radicals from the denominator and reduce the index of the radical if possible. Without any problem.